I welcome you all in this session. Today we will discuss construction of DFA. In the previous two sessions, we had discussed construction of DFA that accept set of all strings over A and B of length exactly 2 and at least 2. Today we will discuss construction of a DFA that accepts set of all strings over A and B of length at most 2, that is less than or equal to 2. So in order to construct a DFA, first we have to find the sigma, that is A and B. The language L will be finite because the length of this string is fixed, that is 2, and we have to include an empty string epsilon, and all these strings of length maximum 2. So now we have to construct a DFA. For this, we will try to draw a skeleton of a DFA that can accept a string of maximum length belongs to this language, that is 2. So we are taking first input string AA for this DFA. So initially consider only the state C is final. Then I will tell you why I have made state B and A as final. So we are considering only state C is a final, and we are checking for input string AA. So from initial state A on input small a, the next state will be B. From state B on input small a, the next state will be C, and C is a final state. So our string of maximum length 2, that is AA, will be accepted. Now we should check for the string of length 1. So in order to accept the string of length 1, we have to make the state B as final. Then only we can accept the strings of length 1. Now we can cross check it. From initial state A on input small a, then next state will be B, and we have made B as final. So our input string A, that is of length 1, will be accepted. Now we have to make one more change in this DFA. We have to make the initial state A as final in order to accept the empty string. So now our DFA can accept empty string, string of length 1, string of length maximum 2, but a DFA must accept all the string that belongs to the language, as well as it should reject all other string that do not belong to this language. So in order to do that, we have to add one more state, that is D, like this. Now we can cross check for an input string of length 3 from initial state A. On input small a, the next state will be B. From state B on input small a, the next state will be C. From input small a, from state C, the next state will be D. And D is not a final state. So the string of length 3 will be rejected. Now you can cross check for any string of length 4, 5 and more. So this DFA will reject any string of length greater than 2. So this DFA will accept only strings of length at most 2. So this is our final DFA. Now what are the observations we have made in this example? To accept an empty string, we have to make initial state as final, and in order to draw a minimal DFA, we should take minimum number of states. For any given language, we can draw any number of DFA, but there is only one minimal DFA which we can draw. So this is all from my side for this session. Thank you for joining.